we're going to jump to the next talk because we've got Yinxi around here somewhere, I believe. Calling Yinxi to the stage. Where are you at?
Hey, I'm here.
Hello. You are awesome. So, one thing, I imagine you want to share your screen, right?
Yes.
All right, you want to get that rocking. And in the meantime, I am going to encourage people to so you're actually currently working at Databricks, right? And I'm
Yes.
going to encourage everyone to check out the Databricks booth that we set up and give a huge shout out and thanks to Databricks for sponsoring this conference, because without their love and support, I don't know what we would do. I did it earlier, but I'm gonna go ahead and do another little product placement right here. This is mm.
I think I'm okay.
Oh,
Can
there
you
we
see
go.
my
Cool.
screen now?
We got it.
All right.
Nice. Excellent. So I will be back in about 20 minutes. And for anyone that has questions, this talk, it's going to be another long talk, not the lightning talk. So we'll be able to ask questions at the end of it. Feel free to jump in the chat with your questions. All right. I'll see you in 20 minutes.
All right. Thank you so much for the introduction. And hello, everybody, and welcome to this session. We'll talk about LLMOps, what challenges LLM brings compared to MLOps, and how we make adaptations. Um, First of all, like who am I? A little bit of self-introduction. My name is Yinxi. I'm a staff data scientist at Databricks. I've been with the company for 3 years. I work with our customers to deliver and deploy GenAI product on Databricks platform. All right, throughout this talk, we want to, let's see, okay. So throughout this talk, we want to talk about different generative AI design patterns and deployment strategies. We want to emphasize and shed light on LLMOps. It is basically trying to assist and automate the iterative development of GenAI applications. We want to walk you through each of the component in the LLMOps loop, including understanding business use case, data exploration and analysis, pipeline prototyping, and how do you package, evaluate model, and use CI/CD tools to deploy the model into production. And in the end, what are the different serving options you have when it comes to LLMs? All right, without further ado, let's jump into it. This diagram here basically shows the 4 different patterns of Gen AI system and application design. It's going from different maturity levels. At the beginning, you want to start from basic off-the-shelf LLM models and do prompt engineering to craft specialized prompt so that it gives you expected behavior and good answer. As you mature through the knowledge, we can start to develop and design a RAG system which combines LLM with and custom external additional data. Until this stage, with prompt engineering and RAG, we are not touching the foundation models, right? We will just be providing additional information to the model, but not changing any of the model parameters. And moving forward to fine tuning and pre-tuning is basically leveraging your own data to update the model weights, either fine tune it or training from scratch. So usually at the beginning of the stage, you would do prompt engineering and only move up to the next level if first of all, you have sufficient data. Secondly, the current results are not satisfactory. All right, so with a regular machine learning pipeline, the machine learning workflows include 3 key assets. You have your code in the code repository, then you have your data. Most of the case is tabular. And in addition, you will have your machine learning models. All those three key assets will need to be developed in the development state, in the development environment, and then tested in the staging environment, finally deployed to production. So from dev to production, you can think of it as from a more open environment to a more closed environment. And you would want to limit restrict and limit human interactions with the prod environment and delegate a lot of the control to CI/CD tools or service principals. That's for MLOps. So how does LLMs make a difference, right? The first thing come to mind, of course, is the change in terms of models. Instead of having regular sklearn or XGBoost model, now you have large language models. The popular generative models are usually have billions of parameters, and even smaller classification models like BERT have millions of parameters too. So how do you interact with those large language models, right? And you can either have like a local downloaded version of it or interact using LLM APIs by providers like OpenAI or Cohere or Mosaic ML. So the interaction with models are different comparing with conventional ML pipelines, and it usually requires a GPU infrastructure. And then let's think about data. For conventional machine learning models, it's usually tabular data, but for LLMs, your input data are raw text. And actually, even before the input to the LLM models, at the beginning, you might start from unstructured data document format like PDF files and image files, and you need to parse it into raw text. We mentioned prompt engineering and RAG all depends heavily on prompts. So your prompt is a big key part, a big key addition to your raw data. In the case of RAG, the external documents and knowledge base are embedded into embeddings and stored in vector database. So raw text, raw input, unstructured input, prompts, and embeddings are on our additional format of data you will need to use in a GenAI system. So that makes like GenAI ops or LLMOps more challenging than regular LLMOps. And throughout the remaining of the talk, we'll try to explain the LM ops lifecycle and trying to I will try to walk you through the key components in the lifecycle step by step. Usually you would start from the development stage, right? And at the development stage, we start from a business problem and trying to understand this business problem with existing data, do data analysis and discovery, and then start to prototype your pipeline code, either prompt or RAG. Once your code is ready, we want to think about how do we package this pipeline or package this model to prepare for deployment. And we do evaluation and model validation before we actually deployed it to production with CI/CD tools, which will help with the unit testing, integrate automated testing and automated deployment. Let's first start from business understanding. It is really, really important and critical to ground LLMs in real life problems. Before just jump into the world of LLMs and start experimenting different type of foundation models, maybe you should ask at the beginning, what is the problem I'm trying to solve? Do I have sufficient data, and can I define a quantified success criteria? Because you will only those solves a real problem that can be deployed into production and generate real returns, right? And also, the use case will decide what type of tool stack you can use. Are you thinking about a chatbot where you will need generative models like ChatGPT or Llama 2 or Mistral? But in the case, if you only need something like a PII de-identification, it is basically a classification model, and you don't need all those large generative models. Model like BERT is suitable and more appropriate for those classification use case. And you also want to think about how does user interact with the solution, right? Is real-time response required? If so, what are the throughput and latency SLAs? Those are the things to define at the design stage, and do a little bit analysis of your query type. If this is, say, a chatbot, what kind of questions people usually send to it, how long is it, what are the context generally looks like, and how once you build this chatbot, how does the user interaction looks like? Is it going to be a UI, and how does it integrate it with the rest of the existing system? Are all things you want to consider from the business design point of view. Then the next step is data exploration and analysis. Incorporating proprietary data into LLM-powered applications provides additional context to LLM and make it more performant and reduce its hallucinations. So understanding your data available for LLM is critical. This is very similar to the conventional machine learning world. You spend a lot of time profiling your tabular data, creating visualizations, and trying to understand the insights of the data before jumping into conclusions and jumping into model design. We should do the same in the case of LLM use cases as well. Profile your existing text, profile your query examples, and understand the size of the size and nature of your document collection. If your data has specific language, specific domain language, keep that in mind. And when search for models, pay additional attention to the models that has been trained on similar data that might give you a little bit of an edge comparing with off-the-shelf data model that trained on general public data. And how frequent the documents are updated are important in the design as well. So leverage your data, and we'll get to more details of how data plays an important role in the RAG sections in slides later. All right, then it comes the most fun and exciting part is to prototype your pipelines and code. With the time limit, in this talk, we'll only cover the prompt engineering examples and RAG examples. So prompt engineering is basically articulate your language so that you communicate better with LLMs and it do what you want it to do. For moms and wives in the audience, I would use this analogy that think of talking to LLMs like telling your kid or husband to do laundry. It might not work that well if you just say, honey, could you please do the laundry? Of course, sometimes it will understand it, but most of the case, you need to provide more clear, concise, and step-by-step instructions, right? We'll say, honey, could you please collect all the dirty clothes and socks in your house or on the floor, put it in the laundry basket, bring it to the laundry room and put it in the washer once it's done, like make sure you transfer them to the dryer and dry them. And we also need to provide a few examples, right? You would tell them, hey, could you please separate whites from colors and use different detergent for different fabrics. And this is still, sometimes this is working pretty well, but you probably need to provide additional information, like tell them how to behave, right? If you don't know how to deal with one of the clothes, come bring it to me and ask me. So same thing, when interacting with LLMs, provide them the step-by-step way of thoughts, and then giving them examples and asking them to say, I don't know, when you don't have relevant information, trying to reduce hallucinations. Um, Unlike humans, LLMs probably don't need all those emotional prep and encouragement, but it is more prone to hacking. In the case of doing laundries, you should be really alert if they say, hey, can I just bring this to the laundry store and can I use your credit card? So that's like a similar sign of prompt hacking that you should be aware of. All right, all the jokes aside, a couple more calls about prompt engineering. Prompts are model specific. One prompt, the same prompt for used for different models generally produces different results. And also models tends to have different way of different syntax of guard your prompts. If you have used the Llama 2 and Llama 2 variant models before, basically its system message is braced by the all uppercase INST characters, which represents for instruct. And like ChatGPT have different prompt syntax than Llama 2. So just pay attention to what are the required best practice for different models when you're experimenting with them. And the recommended best practice for prompt engineering is to go from simple to complex. You want to use tools like MLflow to track your prompt queries and also check your responses. This is similar to the hyperparameter tuning we would do in conventional machine learning, right? You want to keep track of all the experiment trials and then figure out the best hyperparameters. In this case, you want to figure out the best prompts. And to streamline and modularize the process, use prompt templates. Framework like LangChain and Llama Index all have prompt templates. The more advanced use case would be to automate the design process using packages like this one linked here is DSPy developed by Stanford. And now we want to talk about RAGs, right? RAG is basically a dynamic solution to foundation models out of the shelf. Foundation models, first of all, are trained on public data. Hopefully, you haven't seen your proprietary data before, right? So if you could provide that additional context to the LLM, it kind of reduce that limitation. The other limitation of foundation models is they are trained on historical data at a cutoff before a cutoff snapshot. So if same thing, if your data is constantly evolving and providing that new information as context to LLM definitely helps. From the user point of view, the interaction with LLMs of RAG still looks the same, right? User would ask a question using prompts and then generate the answer. But under the hood, the system actually do a few additional steps. So it will first embed the user query, and then this is where the vector database plays a role here. It will go into the vector database and do a similarity search to find relevant documents which has like a closer cosine score with the query, and retrieve that relevant document, use it as an augment to the context, and generate a new prompt with retrieved document together with our original query, and then send that to the LLM to generate the final answer. So if you have your source documents, you will need to have like a evolving, like a constantly refreshing data pipeline that generate embeddings from source documents to embeddings that stored in vector database. The usage of vector database adds like additional component to LLM systems, and also require us to pay attention to embedding refresh, and also um, model packaging for LLM pipelines. Benefits of RAG includes, of course, like providing the external knowledge database to foundation models so that they have up-to-date and more context-relevant responses, and thus this will like reduce hallucination and give the system an edge with understanding of domain-specific questions. This is also more cost-efficient comparing with fine-tuning or pre-training foundation model. So without changing the model parameters, you are still able to generate relevant results just by providing external knowledge base. All right, and then let's talk about like model packaging, right? So we mentioned all the different component that is unique to LLM, and that brings new challenges for model packaging. Instead of packaging just one regular model, you might want to package a model chain, which includes prompts, the model itself, the integration with vector database, etc. If in the case of pre-training or fine-tuning, you will have like customized model, and you can, if you have like additional pre-processing logic and post-processing logic, then you need to like package it as customized model as well. Before we talk about like solutions of model packaging, I do want to like call out the trade-offs between using third-party APIs and self-host models. With the time limit here, I will gloss over the latter two aspects, which is predictable and stable behavior and vendor lock-in, and really highlight on data security and privacy. I have been working with customers in verticals like healthcare and finance. They have really strict data security review system and governance using third-party APIs, which involves sending data to external servers. It's a big risk to concern. So they would prefer to host their own models in their own secure environment to like get full access to the model and avoid data leakage. And then coming back to model packaging, MLflow tools like MLflow has like really nice integration with different frameworks and can help streamline the process of packaging LLM pipelines and prepare for model deployment. MLflow now supports built-in flavor like PyTorch, TensorFlow, Hugging Face Transformers, OpenAI, and LangChain. The integration with Llama Index is on the roadmap and probably will be released soon. And I provided like the two simple APIs you can use to log and track your LangChain chain. And in terms of deployment, you can use the MLflow deployment API to deploy your LLM structure to cloud providers like Azure, AWS or Databricks. All right, evaluation and model validation. I want to be like conscious of time here, so I'll probably gloss over this section. And evaluation is a very challenging and evolving domain right now. The field has a consensus that now it lacks evaluation rubrics and also high quality evaluation data sets. And the current landscape, we have like a few popular benchmark data sets. This one is from this diagram on the right side of the slide is from Mosaic's model GovNet. And it's been a popular choice to use LMs as evaluators too. So Databricks have a really nice blog post about it. We evaluated different model choices and different evaluation rubrics configuration to test the performance of using LLM as judge. Of course, the ideal solution is to have like human feedback in the evaluation. So when designing the LLM systems, always keep in mind to provide the interface that human users can provide a feedback when seeing the UI and seeing the results. It's going to be beneficial. All right, next we are going to talk about like CI/CDs. Again, I want to be mindful of time here, and we'll just gloss over the CI/CD content here. Basically, typical CI/CD pipeline have those steps. Like developers will build their source code and commit changes, and then run the test, deploy the code to staging environment, and monitor the performance, make sure everything behave as expected and have some stable performance, and then deploy it into production. For test, you want to have a lot of unit tests and then do an integration test in the end to do a final end-to-end test from the beginning of data ingestion to the final user-facing API or user interface. Benefits of CI/CD, of course, is like automated test and helps catch regression errors at the early stage and reduce frictions in the model iteration and pipeline iteration stage. And the last component in the ops system we want to cover here is serving. There are different like serving options. You can do if you don't require a real-time response. Of course, batch and offline serving is a good choice. Spark have a really nice and neat module called Pandas UDF, which can help distribute the serving across multi-GPU clusters. And in the case of real-time serving, you need to think about how to package your LLM API call and pre and post processing logic. All right, and we have a reference architecture on the Lakehouse platform for RAGs. So basically, you on the Databricks Lakehouse platform, we recommend to save your objects and assets into Unity Catalog, and then you have different components of the pipeline. This is in the production environment where you will have your vector search database update, and that's a separate pipeline, and not separate pipeline. That's like a refreshing data pipeline, and then the updated vector database will be used in the RAG pipeline as well. So you'll have lot LLM pipeline development and evaluation, and then this and once that's done, it will go to like pipeline validations. The generated model will be logged using MLflow to MLflow tracking server, and then the packaged model format and MLflow model file will be used for deployment. And you can add like monitoring component to it and generate survey endpoint at the platform too. All right, the key takeaways I want to highlight is for LLM application design, always start from a business use case. Start simple, but plan for scaling. It's remember it's going to be like iterative. Your model development does not stop at the time when the model is first deployed into production, right? You want to keep monitoring the performance and iterative iterate the system constantly, and then understand the challenges introduced by LLMs and find adaptations to it in terms of data security and privacy. Uh, consider to use a centralized API governance and a payload encryption. And one example of that is Databricks foundation models. And then think about how to use vector database and GPUs for serving. And for evaluation, trying to collect the human feedback starting at the beginning. All right, thank you all for staying with me. I'll take a look at the event page and see whether there are any questions I need to answer.
You don't even have to. I've got you covered on this. I think
All right.
there is one question that came through that I specifically want to ask because I think about it quite a bit, and it comes to when you're using LLMs to judge the output and evaluate, what kind of
Mhm.
extra costs can you expect to incur?
Right, that's a great question. So I don't know whether you have seen the paper and article about RAG triad. So basically, you have your input queries, and then you have your retrieved context and final answers. Those are the three verticals of your triangle, and within the three verticals, you have LM as judges to evaluate the context to query relevance, and also context to and also results final answer to query relevance. And you also want to judge the groundedness, whether whether the final answer has any hallucinations or has any information that is not existing in the context, right? So the with this triad, basically it means if you are using LLM as judge for one single call, instead of generating the result once, you are generating the results three additional times because you are evaluating all those information. And yes, it will definitely increase the cost. But on the other hand, we need to think about the opportunity cost here, right? If you don't use LLM as just, what are the alternatives? The alternative will be curate evaluation data set and ask a human, and there has to be humans with domain knowledge, which is usually domain expert to evaluate that.
Yeah.
And what about the cost comparison between those two?
Uh,
So those, yes, I agree. There will be definitely additional costs using LMS judges, and the justification on this is whether it worth it comparing with other evaluation solutions.
yeah. So basically, if you're going to do evaluation with an LLM, that's great and it's going to cost you more, yes, but is it going to cost you less than doing it with a human that actually
Hmm.
knows and understands the answers?
Hmm. Yeah.
Okay, cool. So the other piece on this, I guess, is using an LLM to evaluate versus fine tuning a model. And I guess what I am seeing in this question and I'm realizing is that just because you fine tune a model doesn't mean you can forget about evaluation. And so,
Exactly. Yeah.
yeah,
Evaluation has to be everywhere, right? In all kinds of Gen AI application design, you
yeah,
need to have proper way to evaluate your performance. And only with quantified evaluation metrics, you can make a decision point whether I want to move forward, whether I want to actually deploy this application.
And have you seen, so this is a great one from Linus asking about in the knowledge-based chatbots, do you get better performance with just having knowledge documents or examples of Q&A from human to human queries?
Oh, that's a good point. So I'm trying to rephrase and make sure I understand it correctly, right? So there are two options here, either using like human curated examples as few shots learning
Hmm.
or using RAG to provide additional context. Is that correct?
Yeah, and I think it's even more so, even if you're doing RAG, what context are you providing? Are you providing just random pieces of a knowledge base, or are you providing question and answer pairs?
Okay, yeah, those are all like great discussion points. I actually believe like the LLM is also like similar to any like machine learning models. The more you understand the data in your document, the better, right?
Mhm.
So I've been working with customers and users. I find they spend like a lot of time just working with domain experts to iteratively refine the prompts by providing examples. And do prompt engineering. And then we also like experimented with RAG. And the key to improve the RAG performance is actually how well you parse your data, how well you parse your document. You have to create the context chunks that make sense, that like actually provides useful information so LLM can use it as context, right? I think like with like highly skilled humans curated the prompts doing prompt engineering will achieve like even better or at least at par result with RAGs. But if you design your RAG using that domain knowledge, you will like get like better or on par results as well. It's all about how well you understand and you understand your document and understand your question rather than which technique is more superior.
Hmm. Excellent. So this has been great. There are a few more questions that are coming through in the chat, but I realized we are a little bit over time, and so I'm going to keep us moving because that is what I do. That is my one job today. And
Sure.
I want to thank you so much for coming on here and breaking this whole thing down for us. For all these other questions, I would just recommend you're going to jump in the chat, and so I'll let you answer them in the chat on the platform.
Sure. Thank you so much. I do have a quick thought on the LLM as a judge part now.
Oh yeah.
Uh, MLflow has evaluation metrics for GenAI, and feel free to like try it out. You can use OpenAI or your external models to use to be a LLM judge and evaluate your model performance or for use case like summarization or question answering.
There we go. There it is. So perfect. I love it. And yeah, I'm a fan of ML Flow anyway. This is just another reason to be one. All right. We will be seeing you soon, and we're going to just keep it cruising. Thanks so much.